Yesterday we started looking at our error for Taylor polynomials. So since Taylor polynomials are an approximation, that does mean that there is some degree of error that goes along with them. And we learned our Taylor inequality. That tells us what our error has to be less than. And we kind of figured out that basically the biggest part of that formula that we have to figure out or come up with is this max value that goes on top. Because other than that, the bottom and then out to the side is just going to be the next term from what we used for our Taylor approximation. So we looked at one where that value was just given to you. So like it's going to be, has to be less than 35. So sometimes that'll be the case. We also looked at this one, which was sine, and because we know what sine is, we were able to just put in 1 because we know that sine has a maximum of 1. Same thing is true with cosine if you're approximating cosine. So we have 2 more to look at. So this says find third degree polynomial approximation for e to the x at x equals 1 centered at 0. Use Taylor's inequality to find the range of possible values for e to the x at x equals 1 centered at 0. So this is where it helps us if we remember what our e to the x formula is. Remember what it is. Basically all of our derivatives end up being e to the x, and because we're plugging in 0 for all of those, all of our derivative values are 1 when we're centered at 0, and we are specifically centered at 0 here. So remember that we really just end up with our factorials in front of our x's. So that is our third degree approximation of e to the x. Now, it tells us to actually find the approximation for 1. So I'm looking for p sub 3 of 1. So what am I doing with that? Plugging in 1. So I get 1 plus 1 plus 1 half plus 1 sixth. Yes? So 1 plus 1 gives us 1 half plus 1 sixth would be what?
4 6 2/3. Oh shoot.
4 6 or 2/3. Either one is fine. Okay, and then what would 2 plus 2/3 be?
8/3.
So that would be our approximation. Again, for your response question, we are fine to leave it like that. Okay. Multiple choice question, they are going to reduce it to get 8/3. So that's kind of our first part. And then it asks us to use Taylor's inequality to find the range of possible values for e to the x at x equals 1 centered at 0. So again, remember that our remainder or our error has an absolute value around it, which is what's going to give us that inequality, because I'm going to add it to my approximation for one side and subtract it from my approximation for the other side. But I have to find it first. So remind me, what does my remainder or error have to be less than or equal to? Of? Which is in this case?
3.
So 3 plus 1, which gives us 4 of z. So remember, this stands for the fourth derivative. Divided by? Times? X to the 4. Okay. So remember that we said said that z has to be between what? Where does z have to live?
In between like where your center and
Where my center and my approximation. So what is my interval then that z has to be in?
0.
0 to 1. Alright, I'll okay with that. Because remember, at the end of the day, we are never actually going to find z. Z is just a representation for it is some value in between 0 and 1. But we can't use x because like x is already represented by our p of x, and that represents a different value because x is what I'm plugging in for my approximation value. So that's why we use a different variable of z. We don't have to find z, we just have to know where z lives. So z lives in 0 to 1. And we're talking about the maximum value of the fourth derivative. Well, what is our fourth derivative going to be here? E to the x. All of my derivatives are going to be e to the x, yes? And what do we know about the graph of e to the x? It is exponential. And what does that mean is happening?
Increase.
It's increasing. So where is that maximum going to happen?
1.
At 1, yes? Okay. So if I plug in 1 there, that would be e to the first. Yes? Do we know what e is? 2 point stuff, right? So what does 2 point stuff have to be less than? Pick a nice pretty number. 3, right? So I know that e to the first has to be less than or equal to 3. Yes? So again, this is another value, like our e's, we should be able, for the most part, like even if it was e to the 2x, right? Like e squared, then we can think about what would I get if I square that, and I'm just picking the next value, integer above that it has to be less than. Are we all with me there? Yes, no, maybe? And this is helpful because why do we need that? Why do I need to know that my fourth derivative has to be less than or equal to 3? I have an x value, right? My x value is going to be 1. So that's going to go here. Yes, I have a 4 factorial, that's fine. What do we still need to find though? The max of the fourth derivative of z. And remember, if z lives in 0 to 1, then the maximum value that we have is e to the first, which we just said is less than or equal to 3. Yes? So I'm actually going to make that a less than or equal to sign. Right? So if I know that this has to be less than or equal to 3, then I can say that that maximum has to be less than or equal to 3. So I can plug in a 3 there for that value. Because again, we talked about the hard part of this is basically finding that maximum value. That's what I mean. But we specifically want our error for what? For 1, right? This is just our general error for our third degree polynomial, but we specifically want it for 1. So r sub 3 of 1 has to be less than or equal to, what do I get if I plug in 1 for x? Okay? And what is 4 factorial?
24.
Okay, and what is 3 over 24? 1e. Are we all okay with that? Not technically done with my answer yet though. Yay. Because this would be my error bound. Okay. But we are particularly, they actually ask us for the range of values, which means that I just need to take that bound now. And we know that my interval, so like on the one side, we would take our approximation, which is 8/3. Yes. And I'm going to add my 1/8. And then on the other side, I would subtract my 1/8. And that would be my interval.
Oh, so we wouldn't do like plus or minus 1/8?
That's technically what I did, right? I added 1/8 and I subtracted
You just
1/8.
can't have it as notated that way?
Not if it, I mean, I guess if it, you just would want to be careful because it specifically asks ask you for like the interval, and usually we list an interval as like from this to this. It's just that we're leaving it in this form, so that way we don't have to find the decimal approximation. If you did find the decimal approximation, it's like 2.5 to 2.8. But I would probably leave it like that. Other questions?
So when we're finding that value, like in this example, it was 3. It's not it doesn't necessarily have to be as close as possible.
Correct.
It just needs to be.
It just has to be a known maximum. Just so like for our sine and cosine is going to be 1, and we know that is the maximum, so we can plug that in very confidently. For our other things that, again, remember the whole point of using approximations is that we're looking at graphs that don't give us very pretty numbers most of the time, so like natural logs, e's, things like that. And so again, we want to be able to pick a number that we can confidently say is less than or equal to that thing. And so for us to round up by like a little bit isn't that big a deal.
So if it was like pi, would we do like 3.5, or would it be
Yeah.
okay to go to 4?
Either one,
Okay.
depending on like what the situation was. I will say like if you use 3.5, I would probably write it as a fraction, just because like so much what we get on here is going to be fractions, so that would be the really helpful thing for that. Great. Let's look at one last one, which is given to you from a graph. So we've looked at just given a property, we've looked at given 2 different functions, and now we're going to look at given a graph. So this says, let p sub 3 of x be the 3rd degree Maclaurin polynomial for f. Using the information from the graph of y equals the 4th derivative of f shown below, show that p sub 3 of 1/4 minus f of 1/4 is less than 1/400. There's a lot going on there. So first let's break down some of those words. What does Maclaurin polynomial mean for us?
Center to 0.
Yeah. Not x, c. C equals 0 here. So that's helpful. They give us a graph. So we're going to need to use that here in a second. And then what are they technically asking for us here? The remainder, right? So what I'm looking at is that my remainder is less than 400. And this is actually a common way that the AP test will ask it. It will say, show that your remainder has to be less than something. So again, we're trying to get a fraction that we can confidently say is less than 1/400. So what might it be helpful to look at or write out? Just the remainder formula, right? So our r sub 3, again, absolute value, is less than or equal to the absolute value of what? Of 4th derivative of z over and, right? Because again, we have a Maclaurin, so it's x to the 4th. We're all okay with the initial set?
Yep.
Yes, already. Okay. So again, they give us an x value, yeah, it's going to be 1/4 this time. Yes. That's what we're going to plug in for x. So pretty good there. I already have a 4 factorial, so what is it that we need to find? Our maximum value. Well, this time they give us a graph. We do have to be careful though, because it's not necessarily the maximum of this whole thing. Wait with me? 'Cause remember, where does z have to live? In between my correct. So where's our center? Where is our approximation?
1/4.
That should technically be it's a hard bracket. Because it can be on our ends. Yes, no, maybe. symbol before?
Yeah.
The E.
Oh.
It just means it's an element of.
Oh, okay.
I don't know the bracket.
Hopefully you've seen that. No. This is like a sideways E. Just means it's an element of that interval. You don't have to write it as E. It's just notation. So if we know that it has to be in the interval from 0 to 1/4, what part of my graph am I looking at? 0 to 1/4. Do you notice that over here is what value?
1.
1. So what is each of our dotted lines equal? 1/4. So I'm looking at that portion of my graph right there. Yes, no, maybe. So where is my maximum located?
0.
Okay. And what is that maximum value?
15.
Roughly 15. So I can plug that in. So I have 15 over 4 factorial times x to the 4th. And we're specifically wanting to look at what? R sub 3 of 1/4. Now, this is one of the only times that like you might need to do some simplification. And the reason is because remember that I have to be able to confidently say that that thing is less than 1/400. As it stands, can we confidently say that just looking at that? Not really. So that's why, like in this case, technically you wouldn't be wrong to stop there, but usually it's helpful to go a little bit further so that we can just get a fraction that is easily discernible as being bigger or smaller than 1/400. So what is 4 factorial? And what is 4 to the 4th?
64. Wait, 56.
256. Okay. So from here, right, let's think about, I'm going to get a 15 on top. Yes. Okay. What type of number is 24 times 256 going to be?
A big number.
Big number, right? It's at least going to have to be bigger than what? Yeah, but even if I just looked at, like, made these zeros, right? So, like, 20 times 200 would at least give us what? 4,000, right? So I can at least confidently say that this denominator is going to be bigger than 4,000, yes? And is 4,000 in my denominator going to make me have a smaller fraction than 400? Yes. So then we can confidently say that that is less than 400. And so like, that's why I would say, like, we don't have to simplify this all the way down, but we at least need to get it to a point where I can be like, yes, this fraction is smaller than that fraction. Yes.
So if it wasn't smaller, does that mean like we did something wrong?
Correct. It's not going to say show that it is if it's not. Now it could say, is the error less than this? And then you would be able to say no. But it's not going to like trick you and be like show that it is if it's really not. And that means yes, you did something wrong somewhere.